Good morning, students. Today we are starting the classification of dams. So this is just a proceeding of the topic which was hydel power plants. So one of the topic is classification of dams. So there are basically two types of dams. One is the masonry dams. Second is the fill dams. So in masonry dams, you can see there are three types. First one is gravity dams, second is buttress dams, and third is arc dams. In fill dams, you can see earth fill dam is there and rock fill dam is there. So in next slides, one by one, we are going to study all these types and what are their structure and what are the materials that are used in there and what is its purpose. So let's move to the other slide. So the classification again. So dam, is a concrete structure just to hold down the water in the reservoir which is behind the dam, and we have to maintain a level in the reservoir, and we have to allow the water which is coming in the stream to go downstream as well, and the river should keep flowing as well. So these dams are just an obstruction in the passage of the river so that we can rise the level of water and we can use that potential energy to run our turbines. So different types, again the masonry turbine, masonry type of dams that we are studying here. So masonry types of dams, the first one is the solid gravity dam. So in solid gravity dam, it is the most traditional and most used type because the dam is constructed using the concrete and steel structure. So it is bulky and it is massive, and it is the weight is very high as compared to the other types of dam, and it is a single structure which is stand up vertically in the in the passage of the river. So it is very bulky and massive, and sound rock formation is required. So foundation that is we are using, that should be strong enough to hold that much height of structure. So a lot of gravitational forces will be there. If we are constructing a dam of 150 meter, 200 meter, then a gravitational forces will be there. So we need a strong foundation, and the height of the dam is limited by the strength of the base. Because the base will be stronger, the height can be much higher as we are going to design. And the design is simple, but it consumes a lot of heavy materials, so a lot of concrete will be used. So much amount of concrete will be used in these type of dams. So very heavy, very bulky structure will be there. You can see it from some miles, and it is very height wise it is very high. And this type of dams are more economical, but the initial cost is very high, and they provide safe and economical spillway facility because it is designed in a very big structure. So a provision for spillway can be given very efficiently there. So second type in masonry type of dams is the arc dams. So in arc dams, structure is curved upstream. So curved upstream structure is there. I am zooming the structure. So this type of structure will be there. So the arcs will be there on the platform, and there will be buttress. Buttress are just the pillars which are standing the dam, and crown, this crown or arc, this arc will form a crown on each part. So these type of dams are more economical and stronger than gravity dams, and because the less materials are used there, less concrete will be used, and most of the material we have saved in using the crown shape. And this type of dams are only suitable for narrow valleys because the support is required on both of the sides of these dams, and outward thrust we have to compensate by using the solid rocks. And the water thrust which will be applied on these type of dams, that is the only compression part. So the third type here is a buttress dam. So you can see the structure. These pillars are known as buttress. So this slope in the way or in the passage of the river, you can see it is a slopey. So it will form a triangular shape here, and struts are used here to carry this slope. So this slope is just compensating for the pressure of the water which is coming over it, and this buttress will support it, and this triangular shape will help in maintaining a good balance wherever there is earthquake or other uh, geographical disasters are there. Then this type of structure helps. So the country which are under earthquakes or which are most probable to any type of these disasters, they will use this type of dam, and because it is more stable. So deck, you can say that is a flat deck, and buttress are there. So they are also known as hollow gravity dams, inclined upstream face so that the pressure of water create large downward force which provides stability of sliding and overturning. The water will just slide over it, and this buttress will hold it. And the force is transmitting to a row of buttress. Obviously, there are also safe against earthquakes. So the countries like Japan and Indonesia, they will be using these type of dams. So only 1/3 of the material required that of the solid gravity dam. So there is a lot of cost cutting as well as material cutting for these type of dams. So they will be economical, and their initial cost will be low as compared to the solid gravity dam, and these are triangular in shape. So next category in after masonry dams, last category is the fill dams. So fill dams is a structure where we are filling some solid type of granules, or we are using the sand, or we are using the small stones, and we are creating a structure like that, as you can see in figure. So in figure you can see there is stone pitching on the outside, and impervious material near wall have been used. So a wall have been created in the center, but outside the wall we have formed a triangular structure, and in this triangular structure we have filled impervious material, which is you can say that will not allow the water to pass through it. So small stony type of materials, or some sand, or you can say small concrete, some small these rocky type of formations will be used here. So this type of structure, it will help to stop the water when the river flow is very low, or we can use this type of structure on canals which are substitute from the rivers. So these type of structures are very economical because they require very less materials, and there is no need for reinforced concrete, cements and steel structures. So advantage is they are cheaper than masonry dams. Obviously can be built at any locations, at any canals or at any small rivers. It can be built out because the height is not very high. Height is not that much as compared to the solid gravity dams, and suitable for relatively pervious foundation. Gets stronger with age because the stones, the sand, everything that will with the passage of time that will get stronger, and it can be erected quickly. So it will take less time in installing this type of dam. So second disadvantage of these type of dams, it require more maintenance, and supplementary spillway is required, and fail suddenly without any warning because the materials, it can erode out or swept out along with the water, and it is subjected to erosion. Limited in height is very limited, so only one or two Kaplan turbines can be used on these type of dams. So fill dam, other type is rock fill dam. So these dams are eventually constructed in mountainous regions where the sport of mountains is there, or where the rock is available rather than the sand or other materials. So rock is available in abundant. So small rocks or small rock fills will be used here. So it consists of three parts. Loose rock fill will be there, and you can say the sand of rock, that is loose rock fill, and an upstream dry rubble cushion of laid up stone bonding into the dumped rock. So after this rock fill, loose rock fill, that is like a sand, we will use the big rocks. They will form a meshing around it, and then again after on above of this rubble cushion, we will again use impervious membranes or like sand and this dry rock powder we will use there. So after these type of dams, all these type of dams, there are the spillways, which is an integrated part of the dams. So spillways are just a passage provided to the upstream water. So this passage helps in maintaining the level of water into the reservoir, and it prevents the damage to the dam structure because of the water pressure there. So we have to provide a passage there. So these types of spillways can be used there. Overflow type is there, chute type of there, and shaft spillways are there, side channels are there, siphon spillways are there. So let's discuss it. And you can see overfall spillways as shown in the figure. So water will just flow, or it will slide over the dam, and it will flow over the main dam, and it will fall. After the dam, it will fall into the downstream. So you can see this bucket and lower nap, upper nap, crest part. So this is a passage of water which will be overflowing through the dam to the downstream part. So it is the simplest, low in cost and suitable for concrete dams. It is low cost because we are just providing a passage there, and there may be gate control at the top of the dam, because we can control that water should slide over it or not, and counter weight is provided to lift the gate. And second type is chute type of spillway. So it is a channel made of reinforced concrete slab. So the water will be discharged into steep slope open channel. So we are making a channel after the in between the dam structure. So you can see the water from the reservoir, it will fall in these type of channels, and it will flow in symmetry with the dams, and then it will take the water to the downstream. And these are adapted to earth or rock fill dams, and this simple is design and suitable for all foundations. Then there is a shaft spillways. Whenever we are using a vertical type of shaft, or turbine is installed in such a way that the shaft is in vertical direction, so that is a propeller turbine or Kaplan turbine. So we are giving a spillway in the direction of vertical shaft, and the water will fall on the turbines, and after turbines it will flow to the downstream. So we have to try that there should not be any debris inside the water, so that this passage cannot be blocked. So we don't want it to be blocked. So debris should not be clogging the this channel. So other is side channel spillway. So beside the dam, a concrete channel will be designed, so that whenever required, we will make the water flow through these side channels beside the dam. And siphon spillway is there. Siphon spillway is just a holes made up in the dam part. So in the upper portion of the dam part, holes will be made. So whenever water will rise in the reservoir, it will go to the holes, and it will just fall in the downstream part of the valley. So these were the types of spillways. You can see the diagrams as well. So this diagram of a side channel, and these are of siphon tubes. So spillways, what it does, other advantages are way for juvenile fish to bypass down. So we don't want that the fishes should be trapped inside the channels or in the turbines. So they should be passed using these spillways it decreases oxygen level in water, that is one of the disadvantage, and increases the CO2 level in water. So carbon dioxide is being increased because of these spillways, because there will be a lot of turbulent type of flow in these channels, and it will ultimately make O2 disappear and make a large quantity of CO2 there. So these are the spillways. So these are integrated part of dams. So hope you have enjoyed the video and PPT. So I will email it, and you can just send your feedback form in the Google Forms, in the form of Google Forms, and you can give your useful feedback if desired. Okay, thank you.